Welcome to this section of the winter weather training focusing on measuring liquid equivalent and ice. My name is Jesse Lundquist. I will be leading you through this section of the training. To start off with, you may be wondering, what is liquid equivalent? Well, great question. I'm glad you asked. Liquid equivalent is the amount of liquid precipitation that is produced after melting the snow. Think of liquid equivalent as the amount of rain you would have gotten if the precipitation had fallen as rain instead of snow. Determining the amount of liquid equivalent allows you to know how much moisture or water is in the snow. A wet snow, one that is heavy and good for making snowballs, has a higher liquid equivalent than a snow that is dry and fluffy and is easily blown around after reaching the ground. To start the process, you'll need to bring the outer tube inside. On a side note, I would encourage you to remove the inner tube from your rain gauge if you have one like this, as the inner tube tends to break if rain freezes in it. Plus, the funnel and inner tube prevent snow from falling into the larger outer tube. If you would like a rain gauge like this one, it usually costs about $30. Back to determining liquid equivalent. Once you bring the tube inside, measure out some warm water using the inner tube. Remember this number or write it down. Usually for us, snow doesn't come straight down, so the tube will usually be empty or not have much snow in it. Whenever I want to know the liquid equivalent of the snow, I'll determine where the snowfall is most representative after measuring in several different places. Once I have found a location with a representative amount of snow, I'll turn the outer tube upside down and push it down into the snow. To prevent the snow from falling out of the tube, you may need a stiff piece of paper or a fly spotter as you tip the tube right side up out of the snow. Once you have the snow in the tube, you are ready to proceed to the next step. Next, you will need to measure out some warm water to pour into the outer tube. Once you know how much warm water you have, dump it into the outer tube and swirl it around with the snow until it is all melted. There may be times when you have to add more than one tube of warm water to melt the snow. If this happens, just add the warm water measurements together. Be sure to melt all the snow. If the snow is still slushy, it will cause problems with determining the liquid equivalent later on. Once all the snow is melted, begin pouring the water back into the smaller tube. For ease, I would recommend placing the funnel on the tube to avoid spilling. Be careful not to overflow the smaller tube. You may need to dump and refill the tube if there is more water and melt the snow than the tube can hold. If this happens, just add all the measurements together. Once you have emptied all the water and melted the snow, subtract the total amount of water and melt the snow from the water you added to start with. The result is the liquid equivalent of the snow. Next will be an example of how to determine liquid equivalent. In this demonstration, we're going to go through the process we just talked about of determining the liquid equivalent for snow. So, to start off with, we brought our outer tube inside, and since we don't have any snow right now, we have crushed ice instead of snow in the gauge. And then in our inner tube, we have our warm water. You want to get the water as warm as possible, ideally. That way you know it will melt the snow in the outer tube, excuse me. But you don't want to get the water so hot that you're going to burn yourself. So before we get started, we need to look at how much water is in this tube. And in this case, it is ½ an inch. It's right about here. So now we're going to pour this water into the outer tube to melt the snow. We're going to swish it around, make sure we get all the snow melted. If the snow is not completely melted, if there's a little bit of slush in there, that will cause a problem when we pour it back into the inner tube. So as you can see, we have nothing but warm water, or probably a little cooler water in there now. So next we put the funnel back on the inner tube and then pour this back. Now remember, we had ½ an inch of water that we added to the snow in here, so we got to remember that number. So right now we have, take a look at our measurement. Looks like 65 hundredths of an inch of water total. Now this volume of water includes both the warm water that was added and the crushed ice, or in the wintertime, our snow that was in here. So our total volume now is 0.65. We started with half an inch of warm water. So 0.65 total minus the half an inch we started with is 15 hundredths of an inch of liquid equivalent for the snow that we originally had in our gauge. So that's how you determine the liquid equivalent for snowfall. Ice accumulation occurs when rain or drizzle falls onto an object that is below the freezing point and then turns into ice. This is usually called freezing rain or freezing drizzle. While measuring ice accretion or thickness is easier than determining liquid equivalent, you may need to brush up on using fractions. To determine the thickness of ice on a round object, like a branch, you'll need to measure both sides of the object, but don't include the object in your measurements. For this example, the ice thickness on the right side is 3/16 of an inch, and the 7/16 of an inch on the left side. This adds up to 10/16 of an inch. Take the average and you have 5/16 of an inch for a thickness of ice on this branch. Determining ice thickness on a flat surface is even easier. Just measure how thick the ice is. In this example, the ice is half an inch thick. Let's take just a little bit of time and go through some examples. So for this demonstration, we're going to talk about how to measure ice on round objects. So since we don't have any ice outside for this time of year yet, we're going to imagine we have ice on round objects with this twig and this white candle. So let's say we have ice kind of like this. So looking at it from the side, this is the ice that we have on our fictitious setup here. So how do we measure the ice on a round object? Well, it's actually fairly easy. What you would do is you would take the average of the ice, and to do that we first measure the ice on one side. So on this side it is roughly half an inch, and on the other side here it's also about half an inch. So we add the two sides together. So half inch plus half an inch is 1 inch, and then we divide that by 2 and we get an average of half an inch of ice thickness. So pretty easy, right? So what if the ice is actually more like this on the branch, which is what we normally see, an uneven distribution of ice on limbs. So in this case, we go through the same process. We measure both sides. So on this side, let's say it's about 3/4 of an inch, and on this side it's closer to 1/4 of an inch. So do the same thing, 1/4 inch over here plus 3/4 of an inch is 1 inch, and then we divide by 2, gives us half an inch of ice for the thickness on a branch. So a little bit more complicated than the other example, but that's pretty much how you would determine the ice thickness for an elevated object that is round. For this example, we're going to go through how to measure ice on a flat surface, which, as I alluded to earlier, is quite easy. So in this example, we're going to pretend this twig is a post or something that is upright with a flat top to it that the ice has collected on. And this candle again will be our ice. So I'll stick it on there. So to find out how thick ice is on a flat surface, you just measure the thickness of the ice. So in this case, it is about 1.5 inches, it looks like. And that's all there is to it for measuring ice on top of flat surfaces. Thanks for watching this segment about how to determine liquid equivalent and ice thickness on round and flat surfaces. We look forward to seeing your measurements this winter.